We are going to continue with chapter 1's lesson. So we're going to very quickly recap on data movement instructions. We'll go to the addition instruction, then we'll go to subtraction. And then if time permits, then we will do tutorial 2, one example, and we will see how we can actually use the PIC 18 instruction set. So under the data movement instructions, we have 3 instructions, which is move F, move WF, and move FF. Now, just to summarize, this move F is actually used for which type of movement? From F to W, and move WF is from W to F, and move FF, you can do it from F to F, file to file, working register to file, file register to working register. So all 3 you are able to use for move FF. And the next we actually saw addition instructions. So for PIC 18 there are only 3 addition instructions. Add WF, which means add the content of working register with file register, which we have been doing all this while. Then add the content of working register with file register with carry. Now this is only applies when we are doing more than a single byte addition. So we will see that in chapter 2. And the last one is add literal to working register. So which means you're adding the literal value to the content of working register. And when you do that, the new answer will be stored in working register. Now here's a simple example of addition. Now this addition, we want to add the content of working register to hex 33. Now what is the first thing that you want to... Did you notice? What are the first few things that you notice regarding the address? This hex 33, so which means, what is it? What is hex 33? Or what can you perceive when you see hex 33? Yes, it's access bank. So good. No bank, you don't have to use bank. So now this is an addition operation. So what addition are we performing here? Working register add with file register. So based on the description given for all these 3, out of this 3, 1 we are skipping, so there's only 2. So which instruction do you think that we can use? Which instruction that we can use to perform this addition? Are you all able to understand what I'm asking? Which instruction? Out of the 3, 1 is already out. There's only 2. Yes, add WF. Then add WF also does the same thing. Add the content of working register to file register, right? So we can write that. Add the content of working register to file register. And this add WF has 3 fields. It has F, D, and A. So we need to fill one by one. So what is the 8-bit file register address that we can write? Hex 33. Now you know that this is access bank, right? Now here's a change or something additional. All this while we have just been doing addition and we never really considered where to store. Of course, we either store it in file register or in working register. But now in this example, the answer should be stored, maybe the requirement of the question, the answer should be stored in at hex 45. So here, we can only choose capital F or W, right? So where you want to choose? I'll just tell something, anything else you can. F, file register. Is everyone okay? So when you do this, where the answer will be? Working register or hex 33? The answer will be at hex 33. Now, are we done? We have not fulfilled the requirement of the question. The question says the answer should be at hex 45. So what we should do? We should move the answer from hex 33 to hex 45, right? So this what type of movement is this? This is F to F movement, right? So based on the data movement instruction that we have learned, which instruction that we can use for this? Only move FF we can use, right? So you write move FF. What is the address of the source? S33. What is the destination? Hex 45. Can you understand? Do you know what you're doing? What if you choose to make this as W? So add WF. Same thing, but you choose to store the answer at working register. Now, if you choose the answer to be in working register, later you need to transfer from working register to X45, right? What type of movement is this? W to F. For this, which instruction we can use? Move WF. Is that the only instruction you can use? You can also use move FF. So we can use move WF to hex 45A. Or you can use move FF hex, this is working register, right? Working register to hex 45. Managed to understand? Any questions that you all have? Yes. When you use move FF, you don't need to mention access bank. It will automatically access this 045. You mean the move FF? Oh, when you don't write anything in front, automatically it comes 0. Automatically it becomes 0. 045 actually. So 045 and 45 are the same. So that's why there's no issue there. Any other question? Good. That's very nice questions. Many questions that you all have? Shall we proceed? Now the second example is to illustrate the add LW, add literal to working register. So here's one example. Add the value, now here specifically mentioned decimal 12 to the content of working register. So what's happening here? This is literal plus the content of working register, right? So this is which instruction? Add LW. So you have to use that instruction. So add LW has this format, add LWK, whereby the K is the 8-bit literal value. So how do you write it? You write add literal value to working register D12. Now this D12, you can either write it as D12 or hex C, or you can write at hex 0C, which is also same, because when you write hex C, the 0 in front you don't write because we don't have a value. So but if you write as 0C also is nothing wrong. but don't write C0. Is that okay? So here we have working register. So let us assume there is some value inside working register. Would you like to give any example value of an 8-bit value? Give any example. Why so long? 1 1. Okay, so assume that there's some value already in working register, but now when you are performing this instruction, you're going to add decimal 12 to the content of working register, right? So you're going to add. Now decimal 12 is actually C. So what do you get? D1. So you get hex 1D. Where will this answer be stored? In working register itself. So it will be overwritten with the value hex 1D. Is that okay? So that is at LW. Any question up to this point? So next we will see on the final one, which is on the subtraction instructions. Now for PIC 18 instruction set, there are total of 4 subtraction instructions. So the first one is subtract working register from file register. So remember this, when we say subtract working register from file register, it means F minus W. You're subtracting W from F. So this is the example where you have a single byte subtraction. Now it's a subtraction like this, where is F, where is W? Top or bottom? F is top, W should be bottom. Is that okay? The next one is subtract working register from file register, and also subtract borrow. This one is again similar to add WFC, but this happens whenever you have more than a single byte subtraction. So when you want to subtract this, so you can have F and W. And sometimes what happens, if this byte doesn't have sufficient number, it will borrow from here, right? So when you borrow from here, this is F and W. So you need to minus B right from here, this part. So in this segment, you need to use the sub WFB to indicate that when you borrow, then of course you need to minus 1, right? So you automatically minus the borrow. And this one we will see in chapter 2. So you won't be seeing this now. And then you have something different, subtract file register from working register minus borrow. So this one, the tricky part is just that the W and F positions are interchanged. So which means it will be W on top, F will be down. So it depends on how you want to arrange the sequence. So in subtraction, the sequence, the subtrahend position is actually important. For addition, it doesn't matter how you interchange the number, because you're still going to perform addition. But subtraction, you need to ensure that the positions are correct. Otherwise, you may end up doing the wrong subtraction. So this one also in chapter 2. And we have subtract LWK. Now this is a bit different. Usually when we read the previous one, we always say subtract working register from file. Subtract working register from file, subtract from borrow as well. And this one we say subtract file register from working register. We always used to read like that, right? And this one you may think that subtract literal from working register. but it's actually the other way around. It's actually subtract working register from literal. How do you know this? Refer to your instruction set. Sub LW will be under literal operation. Can anyone read the description? Yes. What does the description mentions? Subtract working register from literal, right? So it is L minus W. So take note of that. For any doubt, if anything is uncertain, always refer back to your instruction set. Is that okay? So here's one example of subtraction. So here subtract the content of hex 200 from hex 100 and store the answer at hex 300. Now what type of subtraction is this? This one is F minus F, right? Do we have any subtraction that allows us to subtract file register from file register? No. So what we should do? What we should do? Some of you said the answer is no. Yes, you should apply the data movement instruction, right? So which one you want to move? Yes, the bottom one. This one you can move it to where? Yes, we want to move it to working register so that this entire thing will now become F minus W, right? But this is the first step. So you need to move first. You need to apply the data movement instruction first. So the data movement instruction that we're going to do is moving from file to working register. So which instructions that we can use if we want to do that? So the first step is we want to move from F to W. For this, what are the instructions that we can use? We can actually use move F and move FF, right? So which one you want to use? Yes? I want you all to participate. Which one? Anything also can. That's the both also we can do. Move FF. So the first thing is we need to move FF. What is the source address? Hex 200. We want to move it to working register. So now this is in hex 200 is in working register. So now we can apply F minus W, right? So which instruction is that? Yes, it is subtract working register from file register. What is the address of the file register? It's actually hex 100, right? But can you write hex 100 here? Why cannot? It's 12 bit. But how can you really be sure that it cannot accept 12 bits? How can you be really certain that you cannot accept 12 bits? Yes? How can you be sure that you cannot accept 12 bits? Instruction set. Say lah. That is the answer. You refer to instruction set. Let's say a confirmation. You can see there's only 8 bits there. You can only accept 8 bits. So what you should write here? No, add here the 8-bit address. You can write 00. And the destination? F or W? You want file. Okay. And this one is Access Bank or bank? So you need to use bank. Have you selected the bank? So you can select the bank here. You can select the bank anywhere before. So which bank you want to select? 2. Bank 1. Right. Why bank 1? Because you want to subtract from hex 100. Are you able to follow what we are doing now? Are we done? What is remaining for us to do? Where is the answer currently? Where is the answer correctly? Currently? Hex 200 or hex 100? Hex 100, right? Because you have stored it in F, which is this one, hex 100. So the answer is at hex 100. But where the answer should be? 300. So you are doing this movement. My pen tip just broke. This is F to F. So F to F. So which instruction we should use for F to F? That is for sure it is move FF hex 100 to hex 300. Now this is not the only answer. Remember just now the move from F to W, we used move FF, but we can also use move F right. If you use move F, what will happen? If you use move FF, what will happen? Move F. You are moving the content of hex 200 to working register, but you have to use bank right here. So this will be bank. In which bank? Bank 2. And then you know you're going to perform subtraction, but you have to select bank 1 here, right? Then you subtract, okay, register, file register 00. Let's say if this one we put as W. This is banked. And because the answer is the working register, either we can write as move FF, move from working register to hex 300, or if we want to use move WF, what do you have to do? You can only write 00 here, and you have to use banked, and you need to select bank 3. Any question up to this point? So with the subtraction, chapter 1 is finished.